Let's go on in section 2.3. We're looking at functions. We've already talked about the definition of a relation and of a function. We've also talked about definitions for domain and range. And, and we looked at tables and decided whether the table represented a function, and we also determined what the domain and range were. Now we're going to do something similar with a graph. Does it represent a function? And what is the domain and the range? Okay, so how do we determine whether a graph represents a function? We use the vertical line test. The vertical line test says if any vertical line intersects a graph in more than one point, then the graph does not represent a function. So let's go ahead and look at some examples here. Let's see here. Maybe we'll come back to this first graph in just a minute, but let's start with the second graph. So what we're saying here is let's imagine drawing vertical lines all over this graph. How many times does the vertical line touch the graph? All right, the graph is this line right here. And so when you draw a vertical line here, it only hits the graph one time. And if you draw a vertical line here, it only hits one time. And here it only hits one time. And if you draw it over here, it in fact hits one time as well, right? Because the arrow here says that the graph continues forever in this direction. Okay, so any vertical line hits exactly once, and so therefore this graph is a function. Okay, and so now let's go back to the first graph. The first graph just consists of 1, 2, 3, 4 points. So if you drew a vertical line here, it doesn't hit the graph at all. And you could draw a vertical line between the points, and it doesn't hit as well. It does not hit any point. And then you could draw a vertical line there, or right on the y-axis, or here at x equals -1. And those vertical lines hit exactly one time, hit the graph exactly one time at those points. So once again, this is a function. Once again, this is a function. Let's go on and let's look at a couple more graphs, and then we'll come back and we'll talk about domain and range for these graphs. So can you see which one is not a function? That would be this one on the end. Here, the vertical line hits twice. Hits twice. So, you know, what is the input here? Maybe it's 1, give or take, right? There's 0 at the origin, and here's 2 out at the edge of the circle. So maybe this is x equal 1. And notice there's 2 different y values for that x value. So that goes right back to the definition of a function that we had in the previous video. And now we can see why the vertical line test is equivalent to our definition of a function. So this is not a function. It fails the vertical line test. We've drawn a vertical line that hits the graph twice, that hits the graph more than once. And so for this particular input value x, there's more than one output. There's 2 different outputs. Okay, we can back up here and look at these other 2 graphs pretty quickly. Wherever I draw the vertical line, even if it happens to be right here at the end of the graph, the vertical line only hits once, or out here further to the left, not at all. So this is a function. And the same thing here with this parabola. we can see that the vertical lines hit the graph exactly once. And of course, we could also draw the vertical line out to the right, and it hits exactly once. I think I mentioned this just a moment ago. You know, the arrow says that the graph continues forever in that direction. So we can imagine the graph going on and hitting the vertical line once. So this is also a function. And so now let's go on and let's talk about the domain and range for these functions. Look at this first one here. The first one is a little different. This first graph is a little different than the others because it's just these 4 discrete points. And so, you know, it might even be worthwhile just to come out to the side and we could write out the x and y coordinates here in a table, just like we saw them in a table in the previous example, in the previous video. So this first point is at -1, 1. The second point is at 0, -1. We've got a point at 1, 2, and we've got a point at 4, -3. And so either looking at the table or looking at the points on the graph, it should be pretty straightforward for us to say that the domain is -1, 0, 1, and 4. And the range, we could write them from least to greatest. That might be nice, although it's definitely not necessary. I'll do it here. It's -3, -1, 1, and 2 for the range, and there we go. Okay, let's go on to the next graph here. This time, the graph is not discrete points. It's a continuous line from left to right. Would be the x values, would be the domain. If we follow this line out to, well, the line is going to the left and down, right? We're not concerned about going down, we're just concerned about going to the left. We can go as far to the left as we like, all the way out to -infinity. And similarly, at the right end of the graph, we can go all the way out to +infinity if we just continue far enough along the line. So the domain is -infinity to infinity. For the range, it would be the same. This time, the only difference is that now we're looking down to -infinity and up to +infinity. That would be the directions for the y values for the range. So notice now we're writing domain and range in interval notation instead of set notation like the previous graph. Okay, so let's keep going here. So when we look at the parabola, again, we're trying to think for the domain, we're trying to think from left to right, the x direction. So if we follow the curve, out, then we're going up a lot, but we're not interested in that right now. We just want to observe that takes us further and further to the left as well, and so out to -infinity. And similarly, at the other end of the graph, out to +infinity. Another way to say this is to say all real numbers, right? The interval from -infinity to infinity is the same as saying the domain is all real numbers. Is the range all real numbers? No, it's not. You know, when we look at the bottom of the graph, it doesn't keep going all the way down to -infinity. It starts from 0. The smallest y value is 0. and then it goes up on both sides towards infinity. And notice we need to put a bracket on the 0 to say that we're actually including the value 0 in our range. Okay, for the next graph, maybe pause the video and try to write it out for yourself. From left to right, we begin at -2 and go to positive infinity. And for the range, we're looking vertically. We're going from 0 all the way up to positive infinity. Okay, for this last graph, this relation is not a function. It's a circle. We studied circles in the previous section, so that's nice. Let's see here. What is the domain this time? Well, if we look at the left end, we're coming of the graph, we're coming out to here. If we assume that we're looking at a circle, if this is 2 out at the right end, then this must be -2 at the left end. Similarly, 2 and -2 in the y direction as well. So the domain would be -2 to 2. And the range would also be -2 to 2. Okay. So we've covered the graphs. I have one question here one more question I'd like to go over here before we finish this video. It says, explain why the equation x equals y squared does not represent a function for y in terms of x. And so the best answer, well, there are a couple ways to answer this. One way is just to pick a value for x, right? Suppose x is equal to 9. Well, then doesn't that give us 9 equals y squared? Usually when we try to solve an equation like this, we write the y squared on the left and the 9 on the right. What's the solution? Don't just say 3. Remember, the square root property tells us there's a plus or minus, and so there are actually 2 answers. There's a +3 and a -3. So what we've got here is an input 9 with an output 3 or -3. So an input with more than one output means not a function. Another way to say this more generally would just be to say, if you have y squared is equal to x, right? That's the equation we're given. Then you can solve that for y. You can say y is equal to plus or minus the square root of x by that same square root property. And then the plus and the minus here show you the 2 solutions, the 2 y values that come from a single x value. Okay. What are the domain and the range? Domain is the set of all x values, and we have to be a little bit careful here, right? What numbers could we plug in for x and still be able to get a real valued solution for y? So of course the domain would be 0 to infinity. X can't be negative. If x were negative, then that would force y to be a non-real complex number. Y can be any real number. Range, the y values can be any real number. And maybe if you think about that, all we're doing with y is squaring it. So you can square any real number. That gives us the range. all real numbers. Also notice when you square that number, the result is always positive. When you square any number, the result is always positive or 0. And so that result is the x value and there's our domain that says all the positive numbers and 0. And then we finished the problem. Just as a footnote, I would show you the graph. I won't try to say too much about how I got the graph, but I'll tell you it's a parabola with a vertex at the origin, and it opens out to the right. And so if we can convince ourselves that this is the graph, then we could use the vertical line test to show that this is not a graph. This is not a function as well. Okay, that's all for now.